Welcome back to our integration by parts series. Today we are dealing with the following integral. It's e to the 2x times sine of 3x dx. Well, we know that exponential does not change its structure under differentiation, while sine of x changes, but still it remains the same after even number of differentiation, like finding derivatives. So we can use it and apply integration by parts here, right? So let's directly write how we'll use it. We can write u as e to the 2x, say, and then let's just compute du. It will be 2 times e to the 2x dx, right? And then dv, we took this as sine of 3x dx. Now v will be what? It will be cosine of 3x, but with 1/3, right? And with a minus, so that its derivative is sine of 3x. I hope this part is clear. Let's write it in a neat way. It's 1/3 minus 1/3 cosine of 3x. Okay, and remember that we want to obtain the form of uv minus v du. Okay, so our integral is equal to minus 1/3 e to the 2x times cosine of 3x minus integral of v du, right? Minus 1/3 times cosine of 3x times 2 times e to the 2x dx. Okay, now we'll just write it in a more readable way, which is we'll put constant out of the integral and we'll have plus 2/3 an integral of e to the 2x times cosine of 3x, right? As you may note, we have similar-ish structure with our previous integral that we are searching for. So we can then conclude that, okay, let's apply integration by parts one more time to obtain the form of e to the 2x sine of 3x, right? And then we can add or subtract, depending on the value of this constant here, e to the integral of e to the 2x sine of 3x to both sides and find the value of this integral itself. Okay, let's apply this and you'll understand it better. But if you have some questions, please feel free to write them for any part of this video. I'll answer them. Okay, now we'll apply integration by parts second time, and I'll do it with a blue color. Okay, we take again u as e to the 2x, then du will be 2 times e to the 2x dx, and dv as cosine of 3x. Now v will be, let's see, it will be 1/3 times sine of 3x, right? Without minus, because derivative of sine of 3x is 3 times cosine of 3x. Okay, now it's equal to, I'll just copy this, but if you're with a pen or pencil, you'll need to write this one more time, plus 2/3. Okay, 1/3 times sine of 3x times e to the 2x minus, right, minus an integral of 1/3 times sine of 3x times 2 times e to the 2x dx. Great. As you see, we have a structure of sine of 3x times e to the 2x again, as I was saying before. Alright, I want to write this in a more clear way. For this, I'll copy this. Then plus 2 over 9 e to the 2x sine of 3x minus, let's open up. Don't forget please about these 2/3. We need to multiply now this with a minus in it. Okay, now 2 over 3 is here. We also have 2 over 3 here. It will be 4 over 9. We have 4 over 9, an integral of e to the 2x sine of 3x dx. Great. Now remember that this whole expression here is equal to e to the 2x times sine of 3x dx in integral. Now, for the sake of convenience, let's just please note that this integral is exactly what we were searching for, and the whole expression here is equal to this, right? And for the sake of convenience, let me denote, well, this integral as, let's say, a, right? So we also have this is equal to a. Now our equality, like remember we are dealing with this equality, this is equal to this, right? We'll have the form of a is equal to minus 1 over 3 times e to the 2x cosine of 3x plus 2 over 9 e to the 2x sine of 3x minus 4 over 9a. Well, also remember that we have some constants here, like say c prime, because we were finding integrals here, like it's the same as this, and I was skipping the part with constants so that I can add them in the end. But we don't need to keep track of them that rigorously, but we need to remember that in the end we should add one. Okay, this is important. So that's why I'm just skipping this part for now. Not that important it is in our steps. Okay, now we need to isolate a because we need to find its value, and for this we just need to put this to the left and then divide by its coefficient. Alright, it will be a times 1 plus 4 over 9 is equal to this expression, making use of this function of duplicating. I can reduce some time here. Well, this will be 13 over 9, right? Right. So, which means that we need to divide this to 13 over 9 as well, like both sides of this equation, to get the value we want. Then it will be a is equal to, I'll write it a little bit here. Now we multiply both sides by 9 over 13 to be correct. It will be minus 1 over 3 times 9 over 13 e to the 2x cosine of 3x, right? Plus 2 over 9 over 13 e to the 2x times sine of 3x. Now this is equal to, let's write it in a neat way. For this I propose just writing 1 over 13 e to the 2x out of the brackets, and then write what is left, which is minus 3 times cosine of 3x, right? And plus what's left here, 2 times sine of 3x, and adding some plus some constant c here. Yeah, and that's our final answer. Let me write this this. Okay. I hope everything is clear up to this point. And if you have any questions, please feel free to write them down. I repeat this over and over because sometimes you may feel shy to write, but please don't. Okay? Here it is, our final form, and see you on the next videos. Bye.